For years, everyone assumed the same thing about a heat wave. It's brutal while it lasts, and then it breaks, and life goes back to normal. Scientists studying how these events actually end just found out that assumption is wrong in a very specific, measurable way. The moment a heat wave finally breaks isn't the moment the danger passes. In a growing number of cases, it's the exact moment a second, completely different disaster begins, and we just watched it happen. In real time, in America's own backyard. So what actually happens inside the atmosphere the instant a heat wave ends? Why does breaking the heat sometimes trigger something worse? And why do scientists say this connection is only going to get stronger from here? The discovery nobody saw coming. Researchers studying weather patterns across Australia and Europe found something they weren't expecting. A direct, physically explainable link between how a heat wave ends and what slams into the same region right after. The finding, published in the Journal of Geophysical Research, is blunt. Heat waves make the extreme rainfall that follows them both more likely and more intense, and that connection significantly raises flood risk in exactly the window when people have already let their guard down, convinced the worst of the weather is past, packing away emergency supplies and canceling the precautions they'd been taking for days. Here's the mechanism, and it's simpler than you'd expect. A heat wave doesn't just heat the air, it destabilizes the entire atmosphere above the region. Day after day of intense surface heating pumps extra moisture into the sky through evaporation. At the same time, all that heat builds up something called convective available potential energy, essentially stored fuel sitting in the atmosphere, waiting for a spark. When the heat wave finally breaks, it's usually because an incoming front or a shift in the broader wind pattern crashes into that high-pressure ridge that had been trapping the heat in place. That incoming system slams directly into all that stored heat and moisture at once. The result is a burst of rainfall far more extreme than the same weather system would have produced on its own without a heat wave supercharging the atmosphere first. Two versions of the same nightmare. Researchers found the sequence plays out two different ways around the world. In the first version, extreme heat builds first, and extreme rainfall follows right behind it, driven by all that stored instability and moisture. Researchers found this specific pattern concentrated across the mid and high latitudes, meaning it's not some rare tropical phenomenon. It shows up directly across North America, Europe, and other heavily populated regions, exactly like the one you're probably sitting in right now. In the second version, the order flips. A massive storm system, often a tropical cyclone, brings the extreme rainfall first. Then the heat that follows in its wake, without the usual cooling effect rain normally provides, produces a delayed extreme heat event. Both patterns fall into a category scientists call compound extremes, two dangerous events linked closely enough in time and space that treating them as separate stories badly understates the real danger. This isn't theory. This just happened. Real cases already back this up. The catastrophic July 2018 flooding across western Japan followed an extended stretch of extreme heat, and it wasn't a coincidence. It followed the exact same pathway. In August 2022, severe thunderstorms tore through Central and Southern Europe immediately after a brutal run of extreme heat days. But here's the part that should genuinely grab your attention. This same pattern just played out across the American Midwest weeks ago, almost exactly as the research predicted. A severe, record-threatening heat dome locked in across the South, one of the most intense on record, pushing pressure readings toward levels not seen since the Dust Bowl. At the exact same time, hundreds of miles north, Indiana got hit with a historic flood. The White River shattered a 113-year-old record. 7 people died. And meteorologists tracking the event confirmed the connection directly. The southern heat dome acted like a wall, blocking the storm system over Indiana from moving the way weather systems normally do, trapping it in place for days, while a separate high-pressure system over the Gulf kept pumping moisture into it. Storm after storm trained over the exact same corridor, dumping more than 11 inches of rain in under 48 hours onto ground that had nowhere left to drain. One connected atmospheric system. Two disasters, each one feeding directly into the other. That's not a hypothetical scenario from a research paper anymore. That's a headline from this month. The ground itself turns against you. There's a second mechanism making this worse, and it's brutal in its simplicity. Extended heat and drought bake soil into a hardened, compacted surface, dramatically reducing how much water it can actually absorb. Think of it like the difference between pouring water onto a dry sponge versus pouring it onto a countertop that's been sealed shut. So when the extreme rainfall that follows a heat wave finally arrives, it doesn't soak into the ground the way rain normally would. It runs off almost immediately, overwhelming drainage systems and rivers far faster than the same rainfall total would if it fell onto healthy, absorbent soil. The same heat wave priming the atmosphere for extreme rainfall is simultaneously priming the ground to turn that rainfall into flooding more efficiently. Two mechanisms working in the exact same direction at the exact same time, stacking risk on risk rather than simply adding it. A second threat: hiding in the smoke. There's a completely different compound danger building that doesn't involve rain at all. And it's specifically an urban problem researchers at the University of Oklahoma have been tracking closely. They found that compound events, stretches when heatwave conditions overlap directly with elevated levels of fine particulate air pollution known as PM2.5, are becoming measurably more frequent and more intense across American cities. These particles are small enough to penetrate deep into the lung, and even enter the bloodstream, driving respiratory infections and cardiovascular disease that emergency rooms see spike in lockstep with these overlapping events. Nearly 98% of the cities researchers studied experienced these overlapping heat and pollution events more often and more intensely than before. More than half saw the overlapping episodes stretch out longer too, sometimes by days rather than hours. The driver traces directly back to wildfire smoke. The same hot, dry conditions fueling larger wildfires are increasingly showing up in the same places, at the same times, as the heat waves themselves. Smoke drifts into cities already baking under extreme heat, and the two threats compound on top of each other, each one making the body's ability to cope with the other measurably worse. When drought and heat team up to kill, there's a third pattern, and it operates on a much slower, quieter timescale, which makes it arguably the most dangerous of all. It doesn't produce one dramatic headline with dramatic footage. It produces sustained, elevated mortality that's nearly impossible to attribute to a single day, spread out across weeks in a way that never quite generates the same urgency as a flood or a fire. A recent study examining more than 183,000 U.S. veterans with chronic obstructive pulmonary disease found that heat waves striking during drought conditions were linked to a dramatically higher share of deaths than heat waves striking without drought present. Roughly 7.4% of deaths were attributable to heat exposure during drought, compared to 2.9% without drought, more than double in a population already vulnerable to respiratory stress. Drought tends to produce hotter temperatures and longer heat waves, and researchers found heat waves striking during drought late in the warm season carried a particularly elevated link to mortality. This exact combination, prolonged heat stacked on existing water shortage, is the same pattern researchers point to behind some of the most destructive wildfire seasons in recent memory, including the devastating 2019 to 2020 Australian bushfires that burned for nearly an entire year straight, and the 2020 California fire season that researchers specifically cited as a textbook case of what happens when compound heat and drought build on each other largely unchecked. Why this summer fits the pattern perfectly. None of this is abstract anymore. This year's heat has arrived as a repeated sequence of heat domes rather than one isolated event. An East Coast dome around the 4th of July, a Western dome that peaked in mid-July with record highs across the Rockies, and a Southern dome intense enough to threaten Dust Bowl-era pressure records in August. Each of those domes has built exactly the kind of atmospheric instability and moisture loading this research describes, and at least one of them has already produced the exact kind of catastrophic follow-up flooding. Scientists warned about in Indiana, with 7 lives lost, a river record broken that had stood since 1913, and more than 100,000 homes losing power in the same stretch of days. Layer on top of that, the broader drought already gripping parts of the West, elevated wildfire activity across Canada and the American Southwest, and a rapidly strengthening Super El Niño actively reshaping the jet stream itself, splitting it into a pattern that's locking storm systems in place for days at a time, rather than letting them move through the way they normally would. This isn't a hypothetical future risk being described in a research paper anymore. It's the specific mechanical setup already sitting over North America right now, this week, producing exactly the sequence of events this research predicted years before anyone could point to Indiana as proof. The bigger, slower threat. Underneath it, there's one more piece worth understanding because it operates on a completely different timescale. And climate scientists themselves have started calling it alarming rather than routine. Ocean heat content reached its highest level in at least 1,000 years in 2025, warming faster than at any point in the past 2,000 years. That accumulated heat is expected to keep fueling more severe weather through 2026 rather than fading, including more intense storms making landfall in coastal communities worldwide, storms that arrive carrying more energy and more moisture than the same storms would have a generation ago. Some researchers have gone further, flagging real concern about the long-term stability of major ocean circulation systems under this kind of sustained heat, specifically the deep ocean current system that helps regulate climate across the entire northern hemisphere. Risk assessments that once sat in the low single digits have climbed dramatically, a shift researchers themselves have described as startling. That's a longer, term risk operating on a scale of years to decades, not something tied to any single heat wave this summer, but it's part of the exact same underlying pattern. A warming ocean and atmosphere that isn't just producing more heat in isolation. It's reshaping how connected weather systems interact, turning each individual extreme event into a launching point for the next one. Why the timing catches everyone off guard. There's a psychological piece to this story that's worth understanding, because it's a big part of why the danger catches so many people by surprise. When a heat wave finally breaks, the instinctive human reaction is relief. Temperatures drop, humidity often eases at first, and the sense of emergency that built up over days of dangerous heat starts to fade almost immediately. News coverage moves on. Heat advisories get lifted. People go back outside, run errands they'd been putting off, let their guard down in exactly the way you'd expect after an extended stretch of genuine danger. That's precisely the psychological blind spot this research exposes. The relief people feel when a heat wave ends is real, and in most cases perfectly reasonable. But meteorologically, that exact moment can be the leading edge of the next hazard rather than the all-clear signal it feels like. The same front that finally broke the heat is often the same system now slamming into all that stored atmospheric energy, and the flood warnings that follow can arrive within hours of the heat advisory being lifted, sometimes overlapping with it entirely. What this actually means for you. So here's what to actually do with this, rather than filing it away as one more alarming headline. If you're in a region that's just come through or is currently in an extended heat wave, the days right after that heat finally breaks deserve the same level of weather awareness as the heat wave itself. Watch for flash flood warnings specifically in that window, since the research shows it carries elevated risk for extreme, fast-developing rainfall. And remember that drought-hardened ground can turn even moderate rain into dangerous flooding faster than it would during a normal wet stretch. If heat and nearby wildfire smoke show up at the same time, treat that combination as more serious than either threat alone, especially with existing respiratory or cardiovascular conditions. And if you're somewhere dealing with both drought and heat together, particularly late in the season, understand that the elevated mortality risk researchers have documented in that exact combination is real, measured, and not just a feeling that things seem worse when they pile up together. The broader lesson from all of this research is that treating heat, drought, flooding, wildfire, and pollution as 5 separate weather stories increasingly misses what's actually happening on the ground. They're linked, sequential, mutually reinforcing in ways atmospheric scientists can now trace mechanistically instead of just noticing statistically after the fact. Understanding those links is quickly becoming the difference between knowing when the real danger from a weather pattern has actually passed and realizing, too late, that it just changed shape, put on a different face, and moved to a different part of the map.